projects. In this video, we are going to explain about the project, which is a novel SVM-based CFS for intrusion detection in IoT network. Introduction of the project. The Internet of Things stands out as a transformative technology with the potential to enhance human life through advanced services. The key allure lies in its ability to interconnect and communicate with a diverse array of physical objects, devices, and systems. However, the inherent limitations of connected nodes, such as constrained computing capacity, storage, power consumption, and data security vulnerabilities, pose significant challenges to the secure and efficient functioning of the IoT network. The project underscores the vulnerabilities of connected devices in IoT networks, emphasizing their limitations in terms of computing power, storage, and susceptibility to cyber attacks. The primary concerns include maintaining the confidentiality, integrity, and availability of data against potential attackers, necessitating the adoption of robust security measures. To mitigate the risks associated with the cyber attacks, the project advocates for the implementation of a security policy centered around the detection and monitoring of unauthorized access. Traditional security tools are deemed insufficient for IoT due to the limitations of connected devices. Instead, the project proposes leveraging intrusion detection systems to safeguard data confidentiality and integrity within IoT network. The project addresses the cybersecurity of objects within IoT network, focusing on the development of a solution that is capable of detecting various intrusions. The proposed approach employs machine learning techniques, specifically using NSL-KDD dataset for classification. The key contributions include a novel feature selection methodology that combines correlation-based selection and as well as the classification of relevant features using support vector machine for both binary and multi-class classification, thereby enhancing the overall security posture of IoT networks. Objective of the project. The project aims to tackle challenges in the Internet of Things landscape, where the rapid technological growth necessitates secure data collection and transfer between connected objects without human intervention. Focusing on the constraints faced by the connected objects, particularly in terms of energy consumption and data security, which is confidentiality, integrity, and availability, the objective is to develop a solution that mitigates these limitations. The primary objective involves proposing an intelligent host-based intrusion detection system using machine learning technique, specifically leveraging support vector machine for effective intrusion detection. Employing the NSL-KDD dataset, the project utilizes a correlation-based feature selection technique to identify pertinent features. This approach enhances precision of intrusion detection by selecting the most relevant features, which are attributes for analysis. The overarching goal is to evaluate the performance of proposed solution. The project achieves this by conducting binary and multi-class classifications, showcasing notable accuracy rates. This performance assessment demonstrates the effectiveness of the developed intelligent host-based intrusion detection system. To implement this project, we need software and hardware requirements. Coming to software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, backend framework of Jupyter Notebook, database of SQLite 3, front-end technologies of HTML, CSS, JavaScript, and Bootstrap 4. Hardware requirements are operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. To implement this project, we have designed various steps in the flow of work. The first step is importing the packages. In this module, necessary Python libraries and packages are imported. This includes pandas for data manipulation, NumPy for numerical operations, matplotlib and Seaborn for data visualization, scikit-learn for machine learning, Flask for web development. The next step is exploring the dataset. The project starts by loading and exploring the NSL-KDD dataset. Here, we understand the dataset structure, feature, and characteristics which are crucial for subsequent analysis. The next step is data processing. In this step, we have substeps. Duplicate data, which can distort analysis. So, this step involves identifying and removing any duplicate entries in the dataset. Drop cleaning, handling missing or irrelevant data by dropping columns or rows that do not contribute to the analysis. Visualization using Seaborn and Matplotlib. Utilizing Seaborn and Matplotlib, this module involves creating visualizations to better understand the dataset. This includes plots like histograms, pair plots, and heat maps to reveal patterns, correlations, and potential outliers. Label encoding. Categorical variables are converted into numerical format through label encoding. This ensures that machine learning models can effectively interpret and learn from the data. Feature selection using select percentile. Feature selection is crucial for model efficiency. This step involves using select percentile to choose the most relevant features for analysis, discarding less informative ones. Appending selected features to X and target column to Y. The selected features are appended to input variable as X, while the target variable is assigned to Y. This prepares the data for model training. Splitting the data into train and test. The dataset is split into training and testing sets. The training set is used for training the machine learning model, and the testing set is reserved for evaluating its performance. Building the model. A machine learning model is initialized. This step involves setting up the architecture and parameters of the model. Training the model. The model is trained using the training dataset. During training, the model learns patterns and relationships in the data to make predictions. The next step is Flask framework with SQLite for sign up and sign in. Flask, a web framework, is integrated with SQLite for user authentication. This step involves creating a system for user sign up and sign in using a secure database. The next step is user gives input as feature values. User input feature values through the front end, providing the necessary information of the model to make predictions. The given input is pre-processed for prediction. The input provided by the user is pre-processed to ensure it aligns with the format expected by the trained model. This includes encoding categorical variables and scaling numerical features. Trained model is used for prediction. The pre-processed input is fed into the trained machine learning model for prediction. The model leverages its learned patterns to generate an outcome. Final outcome is displayed through frontend. The prediction outcome is displayed on the front end of the application. User can see the result of the model's analysis based on the input provided. Now we will know what are the algorithms used in the project. Prior to that, we built the project using two different techniques, which are multi-class classification and binary class classification. Coming to multi-class classification involves classifying input data into more than two classes or categories. Each data point belongs to one and only one class. The goal is to assign the correct label to the input data among multiple possible classes. Examples of multi-class classification tasks include handwritten digit recognition, which is classifying digits from 0 to 9. Image recognition include identifying different objects in images, and natural language processing tasks like topic classification, which is assigning news articles to categories such as politics or sports or entertainment. Coming to binary class classification, it is a type of supervised learning task in machine learning where the goal is to categorize input data into one of the two classes or categories. The two classes are often denoted as positive and negative, which are 1 and 0. The primary objective is to create a decision boundary that separates the data points into these two classes. Examples of binary class classification tasks include spam detection, where detecting spam or not spam, disease diagnosis, which is disease or not disease, and sentiment analysis, which is positive or negative sentiment. In multi-class classification, we used SVM algorithm. It is a supervised machine learning algorithm used for classification and regression tasks. It aims to find a hyperplane that best separates data points into different classes in a high-dimensional space. It is utilized as a baseline multi-class classification model. Its ability to handle multiple classes and find an optimal decision boundary makes it suitable for predicting and classifying various traffic types in NSL-KDD dataset. The next algorithms are SVM with the threshold 0.6, 0.7, and 0.8, and 0.9. These variants of SVM, which are these variations of SVM, involve adjusting the probability threshold for the classification. SVM inherently outputs probability scores for each class, and tuning the threshold allows for flexible classification decision based on these probabilities. These variants are explored to analyze the model's performance at different probability thresholds. It provides flexibility in influencing the model's behavior based on the desired trade-off between sensitivity and specificity. In binary class classification, we built SVM. In binary class classification context, SVM works similarly to its multi-class counterpart, but it is designed to different between two classes, which is differentiate between two classes. SVMs are the foundational binary class classification model for discerning between normal and abnormal traffic. It provides an initial understanding of the system's performance in an simplified classification setting. The next algorithms are SVM with the threshold 0.6, 0.7, 0.8, and 0.9. These variations in the binary context involve adjusting the probability threshold for binary classification decisions, considering SVM's inherent probability output. Tuning the threshold in the binary class classification settings allow for a nuanced analysis of the model's performance. It provides insights into how different probability thresholds influence specific types of misclassification, offering flexibility in decision making based on project's requirement. As an extension, we have used other ensemble models to produce more accurate results for final prediction. And we also built front-end using Flash framework for user testing with the user authentication. We used accuracy, precision, recall, and F1 score, which are performance metrics for evaluating this project. So here we have comparison graphs for all those metrics of the multi-class classification problem. Here we have accuracy comparison graph. Here on x-axis we have accuracy score for each algorithm, and on y-axis we have algorithm names. Accuracy is a measure of the overall correctness of the model. It calculates the ratio of correctly predicted instances to the total number of instances. This is precision comparison graph. It is the ratio of correctly predicted positive observations to the total predicted positives. It evaluates the accuracy of positive predictions. This is recall comparison graph. Recall is also known as sensitivity or true positive rate. It measures the ability of the model to capture all relevant instances. It is the ratio of correctly predicted positive observations to the total actual positives. This is F1 score comparison graph. It is the harmonic mean of precision and recall. It provides a balance between precision and recall, especially when there is an imbalance in class distribution. Here we have comparison graphs for binary class classification. To execute the project, first we need to open the code folder which contains source code file. This is the code folder of the project. This is NSL KDD dataset in which we have NSL KDD data. We use the data for training all the algorithms. This is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. Here we have app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content that to be rendered in the HTML templates. Here we have two model files which contain the algorithm information, and that will be loaded into the project code during runtime. Here we have notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. Here we have signup file, which is the DB file. This file is a database file, which is used to store the user information. Now we need to copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now we need to open Anaconda prompt. Using the cd command followed by the space, we need to paste the copied path and then click on enter. By this, current directory will change to the code folder's path. So here we can see that current directory is changed to the code folder's path. Then we need to type the command python space app.py. So here I type the command which is python space app.py, and now we need to click on enter. This will compile app.py file using the command called python app.py. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, Flask framework will host the application locally at the default address, which is the localhost and the port. So here we have localhost and the port. And now we need to copy this local link provided by the framework and paste it in any web browser. So I'm copying the link. I prefer Google Chrome, so I'll paste it in that. Here we need to paste the link and then click on enter. This is the web page of the project, which is displayed in the browser. And this web page is built by using the Flask framework. Here we can see a register link. First, we need to click on that and enter all the sign up details if we are signing up newly. I have already signed up and I have an account in it, so we'll directly click on sign in. Here we need to provide our credentials, which are the username and the password. So I'm giving my username and the password, and now we need to click on sign in. We have signed in successfully. Here we can see the parameters which are need to be entered. Based on the given parameters, we will get the prediction. So first we will understand all these parameters. The first parameter is service. It is a type of service or the protocol used in the network communication. It indicates a specific application or the function that is associated with the network traffic such as HTTP, FTP or SSH. The next one is flag. Flag represents control information in the packet headers, and provides details about the state of the network connection. Common flags include SYN, which is synchronized, ACK, which is acknowledged, FIN, which is finished, and RST, which is reset. The next one is SRC bytes. It is the number of bytes sent from the source in the network communication. It measures the volume of the data transmitted from the source. The next one is DST bytes. It is the number of bytes received by the destination in the network communication. It measures the volume of the data received by the destination. The next one is count. Count represents the number of occurrences or the instances of a particular event. In this context, it indicates the frequency of a specific network communication pattern. The next one is error rate, which is source error rate. This parameter represents the percentage of connections that have an error at the source. It provides insights into the reliability of the source in successful data transmission. The next one is same SRV rate, which is same service rate. It is the percentage of connections that use the same service or the protocol. It helps understanding how often similar services are used in network communication. Different SRV rate, which is different service rate. It is a percentage of connections that use different services or the protocol. It provides insights into the diversity of services involved in the network communication. Different host SRV count. It is a count of different services observed on the network considering different hosts. It measures the variety of services utilized across different hosts. The next one is destination host same SRV rate. It is a percentage of connections where the destination host uses the same service. It indicates the consistency of service usage at the destination. The next one is destination host different SRV rate. It is a percentage of connections where the destination host uses different services. It provides insights into the variety of services accessed by the destination host. The next one is destination host error rate, which is destination host source error rate. Similar to source error rate, this parameter represents the percentage of connections with the errors as the destination host. It assesses the reliability of the destination host in receiving data without the errors. So now we have understood all the parameters. Now we will do the prediction. Here, as we already mentioned that we built this project for two techniques which are multi-class classification and binary class classification. So first we will do the prediction for multi-class classification. For that, we need to click on this multi-class classification link. So now we will enter all these values. So the service value is 46, flag is 5, SRC bytes are 0, DST bytes are 0, count is 131, error rate is 1, same SRV rate is 0.05, different SRV rate is 0.06, destination host SRV count is 0.7, destination host same SRV rate is 0.03, destination host different SRV is 0.06, and the destination host error rate is 1. Now we will click on predict. Here we got the prediction as there is an attack detected and the attack type is DDoS. Now we will enter the parameters again, but with the different values. So click on prediction and select multi-class. Here I entered all the parameters. Now we will click on predict. We got the prediction as there is an attack detected and the attack type is probe. Now we will enter the parameters again. So I entered all the parameters. Now click on predict. Here we got the prediction as there is an attack detected and the attack type is R2L. Now we will enter the parameters again. I entered all the parameters. Now we will click on predict. Here we got the prediction as there is no attack detected and it is normal. Now we will enter the parameters again. So I entered all the parameters. Now we will click on predict. Here we got the prediction as there is an attack detected and the attack type is U2R. Here, as we have did prediction for the multi-class, we got the multiple types of attacks. So now we will do the prediction for binary class classification. So click on binary class. Here the service value is 46, Flag value is 5. SRC bytes are 0. Similarly, we will enter the parameters. I entered all the parameters. Here, click on predict. Here we got the prediction as there is an attack detected and the attack type is DDoS. So now again click on binary class. And now we will enter the other parameters and see what will be predicted. Here I have entered all the parameters. Now click on predict. Here we got the prediction as there is no attack detected and it is normal. As it is binary class classification, here we got the two predictions whether it is attack detected or not. In this way, if we enter the parameters to the system, then we will get the predictions whether attack is detected or not in the binary class. In multi-class, we will get attack is detected or not. If the attack is detected, it will detect which type of attack it is. So now click on log out. Conclusion of the project. The successful implementation of the intelligent host-based intrusion detection system using support vector machine marks as a significant advancement in cybersecurity. The project addresses critical challenges in detecting and preventing intrusions, contributing to the overall security posture of the networks. Network security professionals and cybersecurity experts benefit from the project's robust intrusion detection capabilities. The intelligent ideas powered by SVM and strategic probability threshold tuning equips professionals with a powerful tool to safeguard networks against potential threats. The exploration of the SVM variants with the different probability thresholds provide decision-making flexibility. This adaptability allows security administrators to fine-tune the model's behavior based on the specific requirements and priorities of the network environment. The user-friendly web interface integrated with Flask and SQLite streamlines the user experience for security analysts. The ability to input feature values and receive predictions through a convenient interface facilitates efficient and informed decision making. The high accuracy achieved in both binary and multi-class classifications positions the project as a valuable asset for security operations. Enhanced accuracy ensures that security teams can trust the intrusion detection system, reducing false positives and negatives, and ultimately improving the overall effectiveness of the cybersecurity measures.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.